Welcome, guys. Welcome to the course. Today, we are going to start the new chapter, and that chapter number 6, named as IP version 6. Before this, we have discussed about all the 5 chapters. Currently, we have discussed the MPLS technology. Okay, so after that, it's required to discuss the IP version 6 as per the syllabus. In this lecture, what we are going to discuss, we are actually fortunately starting the basics of IP version 6. In this lecture, why IP address 6 is required, why there is a delay in adoption, and the IP version 6 features we are going to discuss. So let's talk about the IP version 6 basics. My first point, why IP version 6 is required. So if we look at the scenario nowadays on the internet, so there are new computers are available and the new communication technologies are available. If the new technologies are available, the new possibilities and needs are required. So to tackle such a scenario where the enormous number of computers are available, to tackle that, to communicate that computers, we require technologies. The new technologies has been invented. Then it is also the possibilities and needs are also new. Then different kinds of applications also built. So for this purpose also we required IP version 6. The new way is used to interact means new protocols are needed. So if we are dealing with such a large scenario, so we required some protocols. And what protocol we have discussed, that is set of rules, that rules to be changed so that it is going to be adopted, it is going to be accepted the working of that new change. So we have to change ourselves if the nature or if the uh, future or let's say current scenario changes. Then also increase the load and the size on the internet. Nowadays it is what big data kind of thing. So load has increased. Then the massive growth means old way is worried. So old way is not accepting the load which is available on the internet. So it is what the again issue. Nowadays, for support for multimedia, it is what now real-time data is available. Everybody's want like the live streaming, VoIP concepts. So for that purpose, it is also required. Security, we required security, communication security, data security, host security, every security system security. So initially in IP version 4, it was limited, application independent, but now it is full feature. Then limited range of IP version 4. I can tell you guys, IP version 4 is what 2 to the power 32 address space, which is almost collapsed. Now, if only 2 to the power 32 addresses are available on the, it is not possible to, because the population and the devices are more nowadays. So it is required to be identify every devices like a fridge, oven, fan, lights. They required identification because what we have IoT concept, what we have cloud concept, we are controlling our devices, home appliances via remote places. So this address space of the IPv4 is limited. It is not possible, but in terms of the IPv6, it is what very huge address space is available for this purpose also. It is very important. Support for mobility. Nowadays, users are wandering. Users travels each time from network to network. So it is required to support the mobility kind of thing. Then hierarchical routing infrastructure. So if you go with the this kind of limitations, guys, nowadays era is very latest era where everything had changed. Everything had changed. So we also need to change, and we also work on accordingly that fashion. But although there is a delayed in adoption to the IP version 6 because of some reason, my first reason will be because of classless addressing. What we have discussed in IP version 4, there is a classless IP addressing available. There's subnetting, supernetting, VLSM. These are the concepts where plenty of address has saved, so that extend the life of IP version 4 to the 6. Second will be because of DSCP. What DSCP, for the temporary purpose, the IP address is getting to that computer, and IP address, after getting the IP address, that what we can say user will work on that particular network and will then remove or go for the other network. So DSCP also has the key point to save the IP address version 4, and then the netting, that is what NAT, network address translation. So these are the reasons, Argel. In network translation, there are one public address getting the more than one private addresses and mapping up between so that the IP address can be saved. So these are the reasons to accept the uh, delayed in IP version 4 acceptance, or let's say come into the pictures. So this is what the basic slide. Then let's talk the limitations about the IP version 4. So I will quickly go with the limitation of IP version 4. Lack of address space, what we have, very less space, that is 2 to the power 32, and it almost exhausted. The weak protocol extensibility. Here, more field were there, the 12, 13, 14 fields were there, the option fields, but not allowed for more parameters. There was option field available, but it not allowed for the more parameters, but not what we have. We have extension header over here. So this is also a drawback or limitation. The problem of security of communication. No means are providing limit to access the information hosted on the network, and IP version 4 has never been assigned for security. So security here in IP version 4 is application dependent. So security less, we can say. The lack of quality service supports. The placement of information about the bandwidth delays required for the smooth operation of some network applications are not supported. So here, if you talked about the real-time data and the multimedia data, so such kind of quality parameters required to be measured perfectly. Bandwidth supposed to be high, delay supposed to be low for the smooth operations. So this is what the lagging. Then the flat routing infrastructure. In earlier internet, address prefix were not allotted to create a summarizable hierarchical routing infrastructure, because nowadays the size of the network is internet is very large. Initially, it was small, so that kind of flat routing is what supportable, but now it is required hierarchical routing. Okay, so this is also a limitation. Configuration. If we talked about IP version 4, guys, it must be configured either manually or through the DSCP. But in terms of the IP version 6, it's going to be automatically. Then prioritize delivery support. So this manually, and manually is some very tedious work for the system administrator. Each time we have to work out. DSCP also is there. Is good thing sign of DSCP, but still it is quite complicated. Then prioritize delivery supported. However, it relies on the new interpretation of the IP version 4 type of services fit, which is not supported for all the devices on the network. Additionally, identification of the packet flow must be done using the upper layer protocol identifiers such as TCP or UDP. So what we are using over here, TCP or UDP, okay, which is TCP is connection less and UDP is connection, TCP is connection oriented and UDP is connection less. So for that purpose, there are used. The mobility is about new requirement for the internet connection devices in which the node can change its addresses as it changes its physical attachment to the internet and still maintain the existing connection. So mobility is what if one node is leaving to that other node, from one node to one network to another network, that mapping is still available there. That is what the quite confusing, the quite name resolution problem occurs. Although there is a specification for the IP version 4 mobility due to lack of infrastructure, communication with the IP version 4 mobility nodes are inefficient. So it is not quite good support for the mobility also. These are the limitations. Then geographic limitations are available. Like if you talked about any country, let's say USA, the most of the addresses are allocated to that particular countries only. So country specific allotments are available. So other have to wait and other have cannot get the addresses to that. And then it supports for the multimedia. It is what very less. It was very less. So if you talked about the limitations of the IP version 4, the more of the limitations are available. So what we have discussed this slide and the previous slide as well, this slide and previous slide as well. So there are plenty of limitations are available. We can have a combine. So this is what the motivation. But in the second slide, what we have separately is predicted the limitation of IP version 4. So in order to overcome this problem or this limitation, what we have, the IP version 6 features. So let's talk about the features and beauties of IP version 6. Large address space, the 2 to the power 128, which is countless, guys, which is 4 times larger than the IP version 4. If we talked about IP version 4, if it got 2 to the power 32, which is what? N to 4, if you do N to multiplication of 4, that will be to the power 128. Any device which wanted to connect it on the internet nowadays will be connected to the with this particular IP version 6, and they can communicate with each other. Okay, this is what the large address space. Simplified header. Here, there are only 8 fields are available. Some of the fields are omitted. Some of the extra extension header has been added. the simplified header format, because if we simplify the header, the processing will be very less to these headers as compared to the RP version 4. End-to-end connectivity. Every host can directly reach to other hosts on the internet with some limitation involved like a firewall and organization policy. If you talked about the nowadays communication, every host, no matter what their computer, no matter this laptop, mobile devices, any digital gadget, oven, fridge, etc., that can be communicated with each other. Nowadays, what we are using the IoT and cloud, IoT with cloud and cloud with IoT, it is going to be successful in terms of in because of only the IPv6. Auto configuration. Here, IPv6 support both stateless and stateful auto configuration mode of its host devices. This way, absence of DSCP server does not put the halt on inner segment communication. Auto configuration is what here in IPv6 manual configuration is not possible. It is not required. DSCP is also not required, but here auto configuration where the link local address is automatically assigned to that interface once it is boot. What we have a separate demonstration video for the auto configuration. Please do watch that video also. This is what the best feature I can say. And auto configuration and renumbering also there are another feature. The faster forwarding routing. The information containing in the first part of the header is adequate for the route to take the routing decision, thus making routing decision as quickly as looking at the mandatory header. So what we have here, the flow label. Instead of looking to the routing table, what we have flow label to first and to decide which is what which one is the next hop. So it here there is additional feature has been added. Then IPsec, Internet Protocol Security. Initially, it was decided to IPv6 it must have the IPsec security, making it more secure than the IPv4. This feature has now been made optional. Here, IP security, what we have optional, but is more powerful. Here, there are 2 to 3 protocols available. Authentication header protocol available, encryption protocol is available, association protocol is available. Okay, for that by using that one, what we are providing the IP security, and separate extension header is also available for that. So this is what the best feature I can say. In terms of the IP origin port, it is what application dependent, what we can say. No broadcasting. It use the multicast to communicate with the multiple hosts, also for any cast support. So here there is a no broadcast. If we talked about the broadcast, it is not available, but Anycast and multicast is also supported. So these are the few features. Let's talk about the other features. Here, mobility is also supported. Mobility is what? Moving on move, changing one network to another changing the node from one network to another network. It is easily possible because of what we have the addresses. Plenty of addresses are available. The mobility feature in IPv6 takes advantages to auto configuration and extension header. Okay. In smooth transition, the mechanism saves IP addresses and NAT is not required. So this what very tedious work it was earlier. Mapping is what required more, but it is not required. So devices can send and receive data among each other. For example, let's say VoIP and any other streaming media can use much efficiently. So smooth transition will be there so that the quality parameter will be resolved and the user can get the reliability and speed as well. Extensibility, efficient and extensible IP datagram. One of the major advantages of the IPv6 is what the header is that it is extensible to add more fragment information in the optional part. What we have 7 extensible headers like fragmentation, source, etc., etc. These are the extension header has been added to provide the additional information to the datagram so the datagram can be identified and more security can be provided. We have a separate video for the extension header. In next lecture probably we are going to discuss about the extension header and the base header. Then aggregation base address hierarchy. Then also efficient backbone routing for the translation. Then it includes the facility for fragmentation and source routing. So here in the IP origin 6, what we have in earlier IP origin 4, source and router in between router can fragment the data that packets, but here only source can fragment the data. So it is what the new feature is available over here. So fragmentation is only possible at the source level, at the center level. Let's talk another features. Here, despite many conceptual similarities in IP-origin 6 has most of the protocol details. So few changes or most of the changes have been adopted over here. The no more private address collision is what the problem in IP-origin 4, but here that problem has been solved because we have plenty of sites available and because initially the private address made using in one organization could be used in another organization. It was possible, but here that problem has been solved. True quality of service, that is quality of service, is also called flow labeling. So here the flow labeling is another separate field is available. With the help of that, the quality of service is going to be provided, like reliability, jitter, delay, bandwidth. These things are going to be maintained, and there are plenty of techniques available to that. Support for the resource allocation. This is what the best feature I can say. In IPv 6, the type of service field has been removed, but two new field has been added, that is traffic class and flow label have been added to enable the source to request the special handling packet, and this mechanism can be used to support the traffic such as real-time audios and videos. If we talked about the traffic class, so here precedence or maybe the priority can be added to the any kind of application, and flow label is what the faster routing mechanism. And these two things are required for the real-time or multimedia, real-time data or multimedia. So this is what very good sign in resource in IPv 6 as a resource allocation for the traffic class. Here the priority is going to be maintained, and here what we have the labeling is what the fast routing can be done on the basis of labeling. Okay, so these are the features, guys, we have discussed, and moreover in this chapters, this is what the basic in which we have discussed about the three things: the why IPv 6 is required, what are the adoption delay, and the features of IPv 6. So these all the features we are going to discuss one by one in subsequent lectures. So this is what the last chapter. I hope, guys, and this IPv 6 features are okay with you. And IPv 6 concept is very important for understanding the current scenario on the internet. Okay, thank you so much.